Hello and welcome. My name is Raghavan Srinivas, and I'm here to talk about a practical approach to operating data service tiers on Kubernetes with Cassandra. Good morning, good afternoon, good evening, wherever you are, or as an Aussie would say, good day. Let's see. This is normally a 3-hour workshop that we recently actually presented at KubeCon. And I'm going to pack it into 1 hour. It's going to be a little challenging. And also the time of day here is not really congenial to talk too much. So I'll try to balance the talk and, do a little bit of demonstrations as well. So with that said, let's jump right in. So my name is Raghavan Srinivas, and for whatever reason, a lot of people around the world have a tough time pronouncing my name, so I just go by Rags. Rags is the easiest way to remember me. Rags, not the richest. I am a developer advocate at DataStax. I've worked with developers for a long, long time, and my really pet project, I would say, is kind of what Rich did in the previous talk. Which is really about kind of doing the inner loop of development. So to make inner loop easier, to make it, something that, developers do over and over during the day, and you realize a lot of productivity gains by making the inner loop very seamless, easy to use, and really, developers shouldn't worry too much about it until they push it to the outer loop, which is really the robust CI/CD with Jenkins, Travis, those kind of things, right? In today's talk, we will talk about, data, which is actually a little different from the Cloud Foundry side of the world, which is where I came from, right? And really, it's not just about, stateless applications. It's really about stateful applications, because most applications, as you know, are stateful. Stateless, very easy to, essentially make it work in a way that, it can self-heal and so on. But stateful applications, on the other hand, are going to be a little different. So we'll take a look at all that. You can tweet me at rags, or you can find me on GitHub or LinkedIn, rags, all different flavors. So, like I said, I've taken the workshop and kind of condensed it into a 1-hour presentation. So we're going to do a quick, kind of talk about how you can do it yourself. If you're not able to follow the presentation and the demos today, and then we'll look at really databases and Kubernetes. This was something that wasn't really was quite unheard of about 5-6 years ago, when Kubernetes was still in its inception. But of course, things have changed now, and we'll see why and how. We look at a open source project called Cassandra, which is goes K8 Sandra, which is really about Cassandra and Kubernetes. We'll look at how we can monitor highly available, scaling up and down. How do you access the APIs? Using what is referred to as Target, which is really a unifying API, and it provides you with document APIs. You can do SQL if you want, which is our version of the SQL or MySQL kind of command line application. Similar to that, we have something called a SQL, and essentially you can do some queries around that, or you can do GraphQL and so on. And then, of course, some of the routine things that as an operator or as somebody operating, a database needs to worry about, like how do I backup and restore? How do I repair if something is wrong, and so on. And then I'll point you at some resources that you can get more information on. Okay. So the easiest way to run most of these is to just look at docs.cassandra.io. It's actually pretty good. And it has instructions for either you can, the nice thing about Kubernetes and kind of the bane of Kubernetes is that it can be in different forms, right? It can be locally in kind or Minikube. I think the previous presentation went through Minikube. You can even install it on K3s. In fact, for our hands-on lab in KubeCon, we used something called a Civo, which is a Kubernetes provider, and they use K3s. So, you can install Cassandra on K3s as well. But of course, if you want to install it on-prem, you can do that as well on Kubernetes, or you can do it on, the public clouds like AKS, EKS, GKE, and different forms, right? Essentially, what you're going to do is you're going to follow the getting started instructions, which essentially has scripts for installing it on the different flavors of Kubernetes, if you will, kind and Minikube locally, or the different clouds. And for the different clouds, we have some Terraform scripts. So if you're a little bit familiar with Terraform, it's fairly easy to get it installed on either of the three clouds. And the process is pretty much the same. You do the Terraform init, and then you do the apply and so on, like what you would do with a typical Terraform script. Once you've finished the getting started and you have a cluster up and running with Cassandra up and running, we use Helm, and we'll look at that in a second. We also moved beyond Helm, and I'll talk about what that means in a second as well. There are instructions from a SRE perspective, a site reliability engineer perspective, who's more concerned about the day two operations, right? Which is about monitoring, backing up, repairing the database and so on. And then there is another perspective, which is from a developer perspective. How do I access the APIs? How do I install my application, and so on and so forth. Okay, so all of these are documented pretty well on docs.cassandra.io, and that will be your center point to get any information. As it turns out, even though I talked about the skepticism, and I'll get to it in a second, of putting databases on Kubernetes, it turns out that Cassandra is actually a pretty good match for Kubernetes. And the reason why I say that is Cassandra was actually designed to be horizontally scalable. I mean, many of the NoSQL databases actually eschew the fact that you want to do scale vertically, or there is a limit for that, and instead what you're going to do is you're going to scale horizontally, right? Or that's really by having commodity hardware, but having a lot of them, so that you can still tolerate some failure in one or more of them by having multiple copies of the same, right? So a cloud application architecture, if you can think about it, is you have applications, you have data, right? Which could be on the infrastructure that your application is running as well, or it could be outside of that as well. So the way it all started, monolithic applications, legacy databases, typically an on-premises data center, right? But slowly the transition is happening where you have like a microservices world and then a monolithic world, and sometimes it's the hybrid world where these two have to talk to each other. The databases are not necessarily always the huge databases that you're used to. They could be like smaller databases, things that teams are comfortable with, the concept of the two pizza teams and so on. And then a lot of times, these databases are front-ended by database as a service, so that you don't need to worry about kind of the maintenance of that. You leave it to some cloud provider, just like you do with the compute infrastructure. So database obviously is also getting there, right? Can I run it all on Kubernetes? Obviously, you can. Microservices. Basically, you can say I don't want to use the database as a service, but instead, what I'm going to do is I'm going to install everything on Kubernetes. And sometimes it makes sense from like a perspective of some of the applications where you don't want to put the data in the cloud for whatever reason, right? So you don't want to use as a service, but you want to do it all yourself. And the nice thing about Kubernetes is, like I said, it provides you with, quite a few options. You can either put it on your own, self-managed infrastructure as a service, right? It could be OpenStack or something like that, right? Or it could be in the cloud. It could be in AWS. It could be in GCP. It could be in Azure as well. It doesn't really matter, right? Because there are ways, again, with Kubernetes that you can install it pretty much anywhere. So if you take this option of kind of running it, mostly ourselves on Kubernetes, this is kind of how the picture is going to look for most of our applications. Most of the, the cloud and self-managed infrastructure as a service, is you're basically using a service provider for that. Some of those parts where you want to, really not put the data on the cloud or in a service, you may want to, keep it closer control on that. It could still be on a cloud, but maybe it's in a VPC. It's basically locked down pretty heavily and things like that, right? So this is kind of how it looks. So most of it is you're using the service providers, but some of them you're using Kubernetes. So one of our colleagues actually wrote a blog which was pretty popular, and this was a case for databases on Kubernetes from a former skeptic. And again, like I said, there was a lot of skepticism about kind of putting a database in Kubernetes, especially given the fact that it was really about the 12-factor apps and being able to kind of self-heal and do things without really the application being aware of any of that, right? And to do that, with data heavy application was really hard. But again, things have changed now. We do a lot of the install, and I think again in the previous talk, I think there was mention of Helm, but with Helm, we use Helm to basically install Cassandra on the multiple flavors of Kubernetes that you may be used to, right? So really, if you want to do it on Kind, if you want to do it on Minikube, if you want to do it on GKE, doesn't matter. You use the same, Helms and some of these install scripts, to make it happen. And for those of you who may be new to Helm, basically it's like a package manager, similar to apt-get, things like that, right? That you might be familiar with in kind of the Linux world. Since we kind of hit the limit on Helm, we built a new Kubernetes operator, and really the operators are the ones that solve most of the headaches when it comes to operating a database on Kubernetes. We actually transitioned from what we called as a Cass operator, Cassandra operator, or simply Cass operator, to very recently, we built a new Kubernetes, and we're still in the process of building it. It's called the Cassandra operator. Okay, and the Cassandra operator actually leverages the Cass operator underneath, and now all of a sudden it makes it a lot easier to have multi-region install, right? So I will show an example today, time permitting, of a multi-region install that I've done kind of manually, pretty much using the old operator, but using the new operator, it does the network magic and the handshake to essentially install it in multiple regions and let them talk to each other. So we do have a data on Kubernetes community, which is pretty active, and this was part of the talk that I did recently. Just feel free to kind of browse through this. If you just do a data on Kubernetes and look through this, it's an open community, very welcoming community, and a lot of resources, both for people who are just getting started and for the people who are already using this and are pretty familiar with it. So, as you might realize, the main thing that we're going to be talking today is this thing called Cassandra. What what the heck does it? What the heck is it? It's really a cloud-native scalable data tier, which makes administration of the database and kind of doing the day two operations easy. That's really the goal for this project called Cassandra. It's an open source project. You're welcome to join, welcome to help us, welcome to contribute. Okay, it's really Cassandra running on Kubernetes, and I think the name is kind of cute. It's called Cassandra. We just refreshed the site. I mean, it's quite a while back, so this is probably not up to date. But if you look at Cassandra.io, you'll get information on all that. Okay. So how do we set up Cassandra, right? Installation. Very straightforward, right? You add the Helm repo. So starting with Helm 3.2, you know that the public Helm repositories are gone, but you have to add them individually. So you just do the Helm repo add and provide the repo, which is helm.cassandra.io, right? You just do a Helm repo update to get the latest updates, and then you Helm install. You provide the name of the data center and essentially what is it that you're installing from these Helm scripts, right? Cassandra, and that's it, right? And you'll see sometimes it's Helm install Cassandra. Okay, but the idea is that you're going to install it from these repositories. Again, it provides you with the Helm charts, essentially for kind, for K3s, for Minikube, for GKE, for AKS, EKS. It just works across these different infrastructure. The docs again is the best place to get started. It kind of walks you through, like I said, each of these install local, Google, Amazon, and Azure as well, right? So it's basically a highly scalable data tier for Kubernetes. From a very high-level perspective, it kind of straddles the line between data and infrastructure. Obviously, the data itself is what is support, or Cassandra uses the data services part of it. But to be able to access the data, you need to be able to, like, let's say I install an application. I want to be able to do ingress easily. I want to be able to do certain things easily, right? So there is definitely the container orchestration part that Cassandra touches as well. And then the critical part is what we refer to as Stargate, which is a unified data API or a data gateway, if you want to think about it, which provides you with access to a document API, a GraphQL API, and certain other API as well. Okay, and really, it doesn't matter which infrastructure I'm running it on, whether I'm running it on AWS, Google Cloud. I think I've beaten this to death, but that's really the beauty of Kubernetes anyway. So what are the different components? This is critical to understand. Once you have an understanding of this, you can kind of dive into each of these different components and kind of play with each of them, right? It's basically a scalable cloud-native database managed via the Cass operator. And as in Kubernetes, the operators essentially they kind of are monitoring the system and making sure that the desired state and the current state are closely in match. If they're not, then it's going to spawn it up, and there is a back and forth between the operator and the different components. So what are the different components? The data gateway component that's provided by Stargate, and you will see each of these components once I kind of dissect a particular cluster. And I have a few running on different infrastructure. Okay, so the data gateway provides REST, GraphQL, and document API. Then, of course, we also we don't necessarily bundle, but you can use traffic as well, with which provides Kubernetes ingress, makes it easier to access your applications. With provides you with like qualified host name that you can use, and you can adjust your DNS and things like that which makes it easier to access your application. There is something called as repair, which essentially is good for repairing and backup and restore. And then, of course, no Kubernetes project is complete without some observability metrics, right? So you can get this observability metrics from Prometheus and Grafana, and hopefully we'll see a few examples of that today. And all of these are obviously packaged and delivered via Helm charts. So they're kind of all, like different subcharts. In some cases, I don't install Prometheus and Grafana. In some cases, I do. In some cases, I don't use traffic. In some cases, I don't. So all of these are optional, providing you with a lot of different combinations of this to work with. But essentially, the concept is the same, right? Essentially, what I do is I take my Helm chart, I point it to a Kubernetes cluster. I've already created my cluster somewhere, right? Either it's on-prem or it's in the cloud or somewhere, right? And then essentially using this Helm charts, I install the different components, right? And how they talk to each other is really, it happens. But I really, as an operator or as a developer, I don't really need to worry too much about that, because all of that, let's say, for example, Grafana, that particular part is down. The operator is kind of watching it, and what it will do is it will respawn that particular part and so on. Okay, and this shows a little bit of the interaction between these different components. How do I monitor Cassandra? Obviously everything is Prometheus, right? So it is a Prometheus stack, and we will see that in action today. And I'm not like a big expert on Prometheus, but if you are, it's no different from anything else. Okay. So essentially Prometheus metrics, you can visualize them using Grafana. So we'll see both of that in action. Using a Grafana dashboard, you can create your own dashboards and things like that, right? And nowadays, open telemetry is becoming very popular. You can route these Prometheus metrics to open telemetry as well, because again, the standards are working closely with each other to be able to provide the best of the different worlds, right? But let's look at Apache Cassandra itself briefly. What is it? It's a NoSQL distributed database. Okay, first developed at Facebook, and you may have heard of, kind of the CAP theorem, which is consistency, availability, and partition tolerance, right? And the idea is that when a failure scenario happens, you can have only two of them at the same time, either consistent and available, or available and partition tolerant. Or CP, which is consistent and partition tolerant, but not all three of them at the same time, right? What Cassandra does is tends to favor availability and partition tolerant, right? And uses a concept of what is referred to as eventual consistency. So we'll see what this means in a little bit, but really the goal or the biggest advantage of using Cassandra is the low latency, high performance that many of our customers expect. In fact, we have this running in, like I said, like at Facebook, they have their own version of Cassandra, Apple, Netflix, FedEx, and so on. There are a bunch of different customers who use this, and one of the things I've consistently heard is that, they don't have to touch this for years. It's just ticking by itself. Data is distributed. We do the sharding. You don't have to worry about the sharding, because that's one of the key things. It becomes very hard to kind of, if you have to do the sharding yourself, because then, you may get into what are referred to as hard partitions and so on. But we want you to define a partition key, and based on that, the data is distributed. So this is distributed based on the partition key, and you will have multiple copies of the same data to have data durability. There's something called as a replication factor. So if you have 3 as the replication factor, which is what is recommended for production, then typically it means that every row is stored on 3 different nodes. Okay, and essentially, even if one of them goes down, you can serve the data from the other nodes. Okay, so this just indicates how the data is stored. But my oversimplified view of this is that it's kind of a distributed hash table or a distributed hash. And I don't need to worry about where it's distributed, how it's distributed, how evenly it is done or not, or whatever. And I don't need to worry about what happens if, the data or a particular node goes down. All that is handled by the platform. And that's really the power of the platform. But the biggest advantage is that, it's like a hash table, which means that you can get order of one access, right? When it's like, it's there, because basically what happens is the moment you provide a key, it hashes to a particular node. It uses something called as a consistent hashing algorithm, and it's able to get you the data right away, right? So this is an example of a Cassandra data across multiple Kubernetes, essentially, different tracks, different regions, and so on, to make it more robust and more reliable. Okay. So how is it highly available? And not a big deal at all. Like I said, if you take a particular data and let's say this particular node is down, it doesn't really matter because there are two more copies, and you're able to serve it up through the other one, right? As and when the node comes back up, the data is again redistributed, and you'll have 3 copies of the same data as well. All of that, I don't need to worry about it. It essentially happens just like that, right? Obviously, the Kubernetes probes itself takes care of kind of node failures, right? So we have an example in the workshop where we take down a node, we take down the data center, and since Kubernetes is self-healing, it's going to come up by itself. You can set these, you can tune this readiness and liveness probe to make it more, to make it react faster if you want, and so on. This basically kind of gives you a different view of this, how I'm deploying Cassandra on Kubernetes. Essentially it's on multiple pods. There are workers, and then of course you have an API that you're going to access, right? But even with all this, just Kubernetes alone is not enough, right? And that's where the Cass operator and etc. come into the picture. Like, for example, how do I set up the networking? How do I set up the ingress? How do I install Cassandra on node 1, node 2, and not node 3? How do I, connect multiple regions and all that? So for that, the Cassandra operators are going to help you, and that is where that is the practical aspect of running your data tier on Kubernetes. Okay, so there are a number of things that the Cass operator takes care of. It takes care of ring initialization, seed node management, rolling reboot of nodes by changing the CRDs, right? Store data in a rack safe way, okay, so that you can provide the affinity, and you will see that in a second. You can scale up very evenly with new nodes. You can replace dead or unrecoverable nodes, and like I said, you can have multiple data centers, and then you can scale up and down pretty easily as well. This is a Kubernetes SIG which meets bi-weekly. I'm not quite sure if we still do that, but maybe worth kind of looking into this. Obviously, we use some of the Kubernetes primitives, right? Especially with respect to data, persistent volume claims, and storage classes being the fundamental building blocks, for the Cassandra database. And this is how, obviously they are all part of the stateful set, and that represents a set of parts with consistent identities. Identities obviously are based on the network and storage and so on. Custom resources, CRDs, central part of Cassandra. But again, if I am an operator or somebody who's relatively new to Kubernetes, I don't really worry too much about this. I will show you some steps of to how do I do my day-to operations? How do I install? How do I back up? How do I restore? And things like that, right? So the operator is the central part. It's building an application, driving an application top of Kubernetes, behind Kubernetes APIs, right? It reconciles the CRD instances, which has states which are defined as spec attribute. So it listens for events and state evolution and does things appropriately. So examples of operators that we used in Cassandra are the Cass operator, which is the Cassandra operator itself, the Reaper operator, which is the Cassandra Reaper operator, and then the Prometheus operator for Prometheus. Okay. So really a Kubernetes operator helps extend the types of applications that run on Kubernetes. And with the Cass operator, you can think of running Cassandra on Kubernetes. Scaling up and down, one of the cool things about Cassandra is it literally scales linearly. Okay, 1, 2, 4, 8, 16, 32. It just keeps going up like that, right? Because a lot of other horizontally scalable systems kind of reach a peak, and then it's not linear anymore. It kind of levels off, right? Not with Cassandra. It really it just keeps scaling. How do I scale up and down? Very straightforward. Again, you use the Helm command. So all that you do is you Helm upgrade and set the Cassandra size to 2 or 3 or whatever as the case may be, right? If you're scaling up, scaling down, whatever, and reuse the values. You can even scale down, which traditionally was tough with Cassandra in general, and definitely with Cassandra as well. Data is distributed everywhere. You can have hybrid multi-cloud options and so on. And then how do I work with data? I know I'm doing a whirlwind tour of all this, but I'll follow up with one with a fairly extensive demo. Hopefully, keeping fingers crossed that everything is going to work with that. So now that as an SRE I've installed Cassandra, how do I provide access to developers, right? And pretty straightforward. Stargate is kind of the unifying API. Like I said, it provides essentially a number of different APIs. And I don't know if you've heard of something called as Astra, which is our database as a service, and we provide Stargate front-ended to Astra, so that you go through Astra, you can use the REST APIs, you can use the GraphQL APIs, and so on. And likewise with Cassandra as well, you will see that there is a Stargate pod, which essentially takes care of this API gateway and provides you with access to these different APIs as well. So the APIs are basically called out here: the REST API, the GraphQL API, the document API, JSON, and SQL, and then gRPC is coming as well. It's not incubating anymore. It's released actually. It's available today. So with Stargate, we'll see some examples how we expose a SQL, RESTful endpoint, Swagger integration, and then of course GraphQL as well. Okay, pretty straightforward to use this as well. So we'll see some examples of this, as I go through the demo. From an operator's perspective, how do I do backup and restore? Pretty straightforward. What we do is we have backup and restore. We leverage Minio, which actually uses the S3 APIs. S3 is something that Amazon came up with, and those are available actually on multiple clouds as well. So we essentially leverage that, and again, the easiest way to do it is just install the Helm, and you can walk through these different steps. How are repairs done? Repairs are the last resort to keep data across Cassandra cluster in sync. And again, this is a nice thing that one of our customers said, which is without repairs, your database is hopefully consistent, right? So you want to be able to have some reliable consistency, whatever that consistency is, and there are some recommendations of how to do repair. But again, the fundamental philosophy is that you install this Cassandra operator, which in turn installs the right operators, and they maintain the state and do the right thing for you. Okay. So so let me walk through the demo now. And feel free to put in any questions on the chat, and I'll try to see if you can look through those. Okay. So let me go with that said. Let me go to demo. All right. So let me start with. I have a bunch of Cassandra clusters running on a different infrastructure. I use this kube context, and you can see here. This is the cluster that I currently have access to, right? So if I do a kubectl get pods, and I'm just going to do an A just to make sure that I get all the namespaces. Okay. So you'll see here a whole bunch of different pods running. So you see here there's Stargate running. There's the operator, okay, which is running, keeping track of various things, right? You can see here there are a number of data centers here, data center from a Cassandra term, right? And each of them is running on different availability zones, right? So you can see here it's running on East 2A, East 2B, and East 2C. So, even if this data center goes down, not a big deal because, 2A and 2C will take care of that. That's the high availability part of it, right? Then you have the Reaper, which is controlled by the Reaper operator. And there are, I don't think I have an ingress set up here, but you'll see ingress in some of the other examples. Okay. So let me walk through some routine stuff that, kind of operators do, and just to make it easy and not having to watch me typing. What I've done is, I've kind of put this all together. So let's start with this. So the first thing you may want to do is find out what your super user password is, right? So, these are all part of the secrets that I provide when I install using Helm, okay? So I get my password, and there is my password, right? So this is the password I'm going to use, right? So the first thing I'm going to do, and for those of you who are using Cassandra, you know that you use a command called node tool, which basically is a power tool for Cassandra operators. So I'm going to run that. So that I didn't copy. So let me run that. So this will kind of give me a overall picture of the Cassandra cluster. Okay. So this gives me status, and basically it tells me whether it's up or down, and it's normal, up and normal, and so on, right? So it gives me a whole bunch of information on this. Another command I can do is I can do info. And again, if you've used, if you're a Cassandra administrator, these tools are very handy. So it gives you, the gossip protocol is on, and that's how it's listening to the other, nodes. What is the heap memory of heap memory? What rack is it running on? So, like for example, if I do 2B, then this should be on USE's 2B and so on. what are the exceptions, what is the load, and so on and so forth. Okay, so pretty routine that you would see. Okay, let's look at the different services that are running on here. Okay, and that will kind of give you an idea of how this whole thing is set up. Okay, so these are all the different services that are running. Obviously, Kubernetes is running, right? Then you have the Cass operator metrics. Then you have the all part. Then you have the DC one, which is data center. Then you have Stargate, Reaper. This is the seed service, which basically, like I said, uses the seeds and a few other services that are in there. Okay. So let's take a look at one example, like the Reaper itself. Okay, so what I'm going to do is I'm just going to do the port forward, which is the easiest way of kind of learning, some of these commands. Okay, so just so that I make sure that I don't have any other jobs running. Okay. Okay, that's good. I just want to make sure that I didn't leave anything from the previous demo or something like that. Okay, so what I'm doing here is I'm forwarding my Reaper to this particular port. Okay, so how do I access this Reaper service itself? Pretty straightforward. All that I need to do is basically go to localhost because I have port forwarded it, right? So as you are aware, that's kind of what you do in Kubernetes. So I'm going to go there. Okay, let's see if I can. Give me a second. My system is a little bit slow today. I don't know why. All right. So this is the Reaper, and basically it gives you the same. Actually, it's probably not. We refresh the screen. And you should be able to see it in a second. So why don't we do this? Why don't we come back to this in a second? Yeah, for some reason, it's a little slow today. Okay, let me kill. Let's try to go back here. See, give it one more shot before I go on to another cluster. So, but essentially what this does is, it provides you with different clusters. What is the, you can set up a schedule. We recommend a periodic repair, which happens automatically so that, your those things are automatically fixed for you and so on. Then you can do snapshots and there are some live diagnostics and so on. All right. So let's go back here. Okay. I think it finally came back here. Okay, let's move on. All right, I'm gonna kill it and try another cluster. Okay. All right. So let me look at some other ones. And again, in the interest of keeping this going, CPU usage is high. That's kind of why it's okay. I'll worry about that later. So hopefully, so now what I'm going to do is I'm going to switch context to a different cluster. Okay, as a developer, I can do certain things. Like for example, what I can do is I can access the Stargate service. Okay, so let's look at this. So basically, I'm doing the same thing. I'm doing a port forward. Okay, and you'll see that, eventually it'll come back. And let's just do a simple SQL into this. All right, so I'm going to go in, do a SQL. And basically, it's going into localhost 9042, which I set it to, the cluster. And here I can describe my key spaces. So you can see, what are all the different ones. I have a Cassandra test, and these are all system provided ones, and so on. So I was able to, execute just the SQL. And let's take a quick look at kind of getting the token for this. And to get the token, I'm, essentially using the localhost 8081 that I again set up port forward to. Okay. And all of this are again documented pretty well. I'm using the username and the password. All that I need to do is use this token to be able to connect, to the endpoint. Okay, so there are a number of different examples. So for example, if I want to do Swagger, all that I need to do is go to this particular URL, right? And I'm going to use the token, right, that I saw just now. So let's see if we can do that. Here's my Swagger. All right, my browser is not very responsive today, so just wondering what's the best way to get over this. Maybe I'll try to do it on my Safari. Okay, even that's a little slow responding, but you get the idea. Essentially, what you're going to do is use that token, and using the Swagger, you can call the different APIs. Okay, so the one thing that I probably want to show you is another cluster, just to kind of give you a flavor. Okay, and this one is a little bit more. So let me go into this particular example. Okay, so I'm going to set the cluster to this. Okay, and again, let's look at the different parts that are running. Okay, so it should be up and running in a moment. So I'm looking at the different parts. Okay, and you'll see here again, kind of very similar. I have them running in West 1, A, B, and C. Okay, so different availability zones, but this is actually running on GKE. Okay, how do I know that? Is there are a number of different ways of. You just do a kubectl get nodes, and you'll see here it's running on GKE. Okay. And one of the cool things here that you will see, if I can get it going, okay, and you can see here in the background, you have Swagger there. Okay, I will show you the node tool and status again. Right. Okay, you'll see here there are two data centers. One is like DC1 and DC2, and actually they are in two different regions. And we'll see this. One is in central, as you can see here, and the other one is in west. The west is the one that we currently are looking in, but they're hooked up together, and it was hooked up very easily. And I can show you how I did that is by just looking at GKE YAML and GKE DC2 values.yaml. So it's two different regions, but the way it's hooked up is using these seeds. So what I did was I installed the data center one in one region and then hooked it up to the other by just providing the seeds. And all of these were in the same virtual network, right? So essentially they were a part of the same virtual network. And if I can go to my Google console, I can show that, but I'm not quite sure if I can get to that right now. Let me see if we can do that. Okay, there it is. So here's my clusters, right? And essentially you will see here that there are two, these are the two ones, which is the central one and the west one. They are part of the same, essentially one part of the big Cassandra data center. And the way the two are interconnected is by virtue of it being on the same network. And you hopefully see that once I dig into it. Okay. So if I go into this cluster, you will see, from a networking perspective, they're using this dev RNS network and the dev RNS subnet. Okay, and if I go back to my clusters again, okay, and if I go to the second cluster, okay, which is on US West 1, they should be on the same subnet as well. Okay, so you can see here they're in the same subnet. So that's how they're able to talk to each other, because they're part of the same subnet. Okay. So hopefully that kind of gave you a flavor of how you can hook these two together. The last thing I want to show is some of the metrics. Let's see if this works. All right, so let's try this. Let's go back and look at the metrics if you can. All right, so here's my Prometheus. Okay, and you can see I can just do an execute. Okay, or I can just do a status. And look for targets. Okay, you can see that it gives me information on the Prometheus and the the Cassandra, the different data centers and so on, which is unhealthy, which is not, and so on. So I can take a look at that. This is Grafana, which is again the visualizer for all these metrics, right? So let me go and look in Grafana. And you can see a whole bunch of information here. The easiest way to kind of get information on this is start on the home screen and then kind of look through the Cassandra overview, for instance, which gives you an overview of how you operationalize your different Cassandra nodes are, and so on. Okay, so you can see here there are 3 nodes on 3 different racks, and you can kind of dig through all of that. Okay, so if you want to go back, or see my changes, go back home, and you can look at Stargate, for instance. Okay, which will tell you how many APIs were done, what time, and a lot of information on that as well. All of this enabled again by Prometheus and Grafana. Okay, so I think we covered most of the demo that I wanted to anyway. Let's see if I missed anything. I was going to deploy my pet clinic application, but I don't think I have too much time. The only other thing I could show is the other part of the cluster, which is the central. But I think it's pretty much the same. So let's skip that in the interest of time. and look at some of the resources. So please join the Cassandra community. Like I said, pretty welcoming community. You can post on Discord, or you can just join, these different community artifacts. Okay. We ourselves at DataStax, we do a lot of developer. Our primary goal is to level up your education. Wherever you are, whether you're just starting or you're a seasoned developer, there are definitely courses that are good for you. In fact, last week, if you're a Java developer, I'm a Java developer myself. We had a Quarkus and Cassandra workshop where we kind of walked through, again, kind of the inner loop of development, where it's so easy to package an application, debug an application, and the creme de la creme was like making it as a native application and being able to run it. So we have a number of different workshops. We provide badges. We also do certifications. That's the information here. But really, the goal is to level up your skills no matter where you are. So love to hear from you. Love to get your feedback. My name again is Rags, and essentially you can hit me up in a number of different ways. It's not very hard to find me. And with that said, I really want to thank everybody for being up. I'd love to take some questions if you have any. But again, thanks again, and have a great day. Have a good rest of the conference, which is almost ending, I'm sure.